polynomial function p of x is equal to x squared minus x minus 12. Find the x-intercepts and determine the behavior of the graph at the x-intercepts. So our polynomial function is p of x is equal to x squared minus x minus 12. So this is quadratic. We want to go ahead and determine the x-intercepts. The x-intercepts are the points where the graph crosses the x-axis, and that is when y is equal to 0. So I'll take the function x squared minus x minus 12, and I'll set it equal to 0. And this particular problem will factor. I know that x multiplied by x is x squared. And if I think about two numbers whose product is negative 12 and whose sum is negative 1, that would be x minus 4, x plus 3. Take a moment to check that. X times x is x squared. This is a positive 3x, a negative 4x, which is a negative 1x, and then negative 4, positive 3 is a negative 12. So now this is factored. Then I'll take each of those factors and I'll set them equal to 0. So I find that x is equal to 4 and x is equal to negative 3. I'm going to come over here and I'm going to make a table. So I have the x-intercept. The first x-intercept is 4, 0. And this occurs one time. So it occurs once. This x-intercept is negative 3, 0. And this also occurs once. And since each of these occurs only once, the behavior of the graph at the x-intercept is that it will cross the x-axis. Cross the x-axis for each of those. The other item I'd like to determine, I'm going to make a quick sketch of the graph here in a minute, is the Y-intercept. The Y-intercept is when x is equal to 0. It's the point where the graph crosses the y-axis. So again, that's when x is 0. So if I take the polynomial function and plug in 0 for x, I have 0 squared. I'm plugging it into this function right here. Minus 0 minus 12, which gives me a value of negative 12. So the y-intercept is the point 0, negative 12. Now I'd like to go over to the graph, and I'd like to plot the point, the y-intercept 0, negative 12, as well as the x-intercepts. So I have 0, negative 12. I've already actually labeled negative 12 here. So I have 0, negative 12 for the y-intercept. The x-intercepts were 4, 0, 1, 2, 3, 4, and negative 3, 0. So the graph is going to go through that y-intercept. In addition, at both of these x-intercepts, since each of them occurs only once, the graph will cross. So it goes through negative 12, crosses at this x-intercept of negative 3, 0. It's also quadratic, so I have an idea of what the shape is going to be like. It's going to be quadratic. And it will come up here, and it crosses at this x-intercept as well. So one thing we say is if the multiplicity, and I can write that here, the multiplicity of the x-intercept is odd, then our graph will cross the x-axis. So in each case, the x-intercept of 4, 0, it occurs only once, and 1 is an odd number. So the graph will cross the x-axis at that x-intercept. As well at the point -3, 0, or the x-intercept -3, 0, that occurs once. So the graph will cross the x-axis at that x-intercept. So for the polynomial function x squared minus x minus 12, we determined the x-intercepts, the behavior of the graph at the x-intercepts, as well as the y-intercept, and sketched the graph.